Hello everyone, today I will be discussing about some static combinational logic circuit. So before going into the static combinational logic circuit, first we have to separate that what do we mean by combinational logic circuit and sequential logic circuit. So combinational logic circuit means the output of that circuit depends upon the present input, and the sequential circuit means output depends upon present input as well as the previous input also. So in case of your sequential circuit, there will be always feedback path from output side to the input side, and as shown in that figure. So that is called state time, that will define the different state of your output. Here the term static means, static signifies that your input will be stabilized when there will be output will be stabilized when there will be defined input signal, well defined input signal. In CMOS logic gate, there will be logic array of pull up transistor and array of pull down transistor. So here pull up and pull down network operated in by input voltages in a complementary fashion. When pull down network conducts for an input combination, the output node establishes a low resistance path with the ground, resulting a zero output. When pull up network conducts, the output node establishes a low resistance path with VDD, resulting with a logic 1 as output. Now before moving into the design procedure, so let me discuss about the complementary properties of our CMOS logic. So here under static condition, pull up network and pull down network never turn on simultaneously. This is one complementary property of CMOS logic. Similarly, pull down network comprises of NMOS and pull up network comprises of PMOS. This is another complementary logic. Pull up network and pull down network are dual of each other. That is, the serial connection of NMOS in PDN is exactly equal to the parallel connection of PMOS in PUN or pull up network. AND function is implemented by series connection of NMOS and parallel connection of PMOS, and OR function is implemented by parallel connection of NMOS and series connection of PMOS. So these are the complementary property of CMOS logic design circuit. So let us move on to that picture. First figure shows that output capacitance is initially charged to VDD. So NMOS device pulls the output all the way down to ground without any voltage drop. So NMOS can pass 0 without VTN drop. So NMOS device generate a strong zeros. So in the next figure, that PMOS switch succeeds in charging the output all the way to VDD without any voltage drop. So we can say that PMOS can pass VDD without VTP drop. VTP means threshold voltage of PMOS. So we can strongly say that PMOS device generate a strong 1. Now let us move on to our design methodology. So suppose first one, suppose you are given some Boolean expression. So first you take the complement of this Boolean expression. Next step is that design the PDN. PDN means pull down network by realizing AND by series NMOS and OR by parallel NMOS. Next, design pull up network just by reversing the pull down network, provided NMOS will be replaced by PMOS. Next, final stage is there, just you connect your pull up network and pull down network, and in between this pull up and pull down network you just get an output from that circuit. So the circuit design has been completed by using this design methodology. So let us take an example how to construct a CMOS logic circuit for 2-input NAND gate. So for your output F equal to A and B bar. So first step that you have to take the complement of that one, that is A dot B. So that is you have to first generate a pull up pull down network. So we use our 2 NMOS transistor in series. Then by using a pull up network, in the pull up network we can use 2 transistor PMOS transistor in parallel. Then combine them, you will be getting our NAND gate. This is shown in the figure. Similarly, in case of your CMOS circuit for 2-input NOR gate, the expression for the NOR gate F equal to A or B whole bar. So first you have to take the complement of that one, so that will be A or B. So first you have to design the pull down network. So pull down network we are using 2 NMOS in parallel because it is a OR operation, NMOS in parallel. Then we just get a pull up network just by reversing this parallel NMOS by series PMOS. This is shown in the figure. And then combine this pull up network with your pull down network and take an output from this junction of this pull up network and pull down network, so that we will be getting F equal to A or B whole bar. So that is the function of NOR gate. So next move on to another example where you have taken one Boolean expression. So that Boolean expression will be that F equal to D or B dot B or C whole bar. So first step is that you have to take the complement of this total expression. So the bar will be omitted, so the complement value is A or B and B or C. So here first one we have to design a pull down network. So pull down network, since B and C will be in OR operation, so there will be a parallel connection of NMOS for B and C input, and since A will be in AND operation with B and C, so A will be in series with B and C. Again, since D will be in OR operation, so D will be in parallel with the rest of the circuit. So this is the pull down network. Then this pull down network will be converted by reversing, converted to pull up network just by reversing this pull up network, pull down network. Just convert your parallel connection to series connection and series connection to parallel connection and change NMOS to PMOS. So in that figure, middle figure shows your pull up network connection. Then combine this pull up network and pull down network, you will be getting the total internal circuit, total expression at that output, and we will be getting that output voltage at the junction of pull up and pull down network. This is shown in the figure. Next, another example is there, F equal to A B or B C or C A. So first step is that we have to take the complement of this F. So F bar will be taken, and for this here A B B C and C A. For this one we first design our pull down network. Since AB will be in the AND operation, so there will be series connection of your series connection of your NMOS, and for BC there will be series connection of NMOS to NMOS. For CA there will be series connection of again to NMOS. So since these are the product is in OR operation, so these three product will be again in parallel to get our entire pull down network. So this pull down network again converted to your pull up network just by reversing our series connection to parallel connection and parallel connection to series connection, and just by replacing our NMOS to PMOS. So here we are getting two PMOS A and B in two PMOS in parallel, C and B P2 PMOS are in parallel, A and C 2 PMOS are in parallel. So the entire circuit will be getting just by adding our pull up network and pull down network, and we are getting that output complement of this output A bar from the junction of this pull up network and pull down network. Since we are getting a complement, this output will be again fed to some inverter that is shown in the figure, inverter Cmos inverter, and exactly at the output of your Cmos inverter we are getting our exact expression. So this is our this is one example of our Boolean expression where we can implement our pull up and pull down network, and by using pull up pull down network we can implement our Boolean algebra or Boolean expression, not algebra, Boolean expression of any logic design. So by using a pull up pull down network it's very easy to realize any Boolean expression. So next one is that y equal to A or B or C whole and with your dot. Hello everyone, today I will be discussing about so next expression is y is here A, B and C are odd with each other, and the total ABC will be ANDed with your D, and the total function will be in bar, that means complement. So first we have to take the complement of y, that is y bar. So A, B and C will be in parallel combination because they are in OR operation, and from this one here D will be in AND operation, so D will be in series with this parallel operation. So we are getting our pull down network. So pull down network basically consists of our NMOS, and we are getting a pull up network just by reversing this pull down network, and series will be converted to parallel combination, and parallel will be converted into a series combination, and again we replace our NMOS to PMOS. So then the final stage is that we just connect our OR operation, connect our pull up network and pull down network, and from the junction of pull up network and pull down network we will be getting our output of that expression, and that is the value of y, and so we can get the exact value of that Boolean expression at that output with the combination of A, B, C and D. Just we can put the value just inside your truth table. We are getting the output from that circuit that is exactly match the truth table of that expression. So this is all about our static combinational logic circuit. Thank you. Goodbye.